Hi guys, welcome back to my YouTube channel, and in today's video we're going to be learning how to implicitly differentiate. This is chapter 2 of Math 31, and I thought this was pretty easy when I was first doing it, so I think you guys won't struggle too much with this. Also, I wanted to say thank you guys for 560 subscribers. I remember up until last week I had like 450, so that's a pretty big jump, so I wanted to thank you guys for that. So let's get started with the video. Okay guys, so here this question is asking, find dy by dx if root x plus root y equals 1. So I went ahead and I simplified the equation in terms of powers. So I did x to the power of half plus y to the power of half equals 1. So it's asking us to find dy by dx. Basically, it's asking us to find the derivative of this. And usually we would be able to just apply power rule and be done with the question. But because this has two variables, we have to add an extra step, and that is when we differentiate y, we're going to add a y prime beside it. Because when we differentiate, it's usually only in terms of x, and since there's two variables here, we're going to add that extra step. So right now what we're going to do is continue this question, except we're going to apply power rule to each term. Okay, I'm going to go ahead and do that. Okay guys, so here I applied power rule to each term. When we applied power rule, it's like normal, I'm not going to go into that. But when we applied it to the y term, we did half y to the power of negative half times y dash. We have to add this whenever we have a term with y beside it. We have to add this. Usually in other videos, you'll probably see y dash as d by dy. That works too. But to keep it cleaner, I like to put y dash. So the next step is to isolate for y dash. When we isolate for y dash and move everything to the other side, we're going to be done with the question because y dash is is the derivative of the whole equation. So now we're just going to isolate for y dash. What we're going to do is move this to the other side and then move this term also, and I'm going to write that off camera so I can show you. Okay guys, so what I did first was I turned this back into radical form so it's easier to do the isolation. This is the same as this basically. So then we started isolating in this step. We moved this term to the other side. Since it's being added here, it's going to be negative here. So negative 1 over 2 root x. And then we move this term to the other side because we want just y dash alone. So since 2 root y is being divided by y dash, it's going to be multiplied on this side, which is why it's in the numerator. So now we have y dash equals negative 2 root y over 2 root x. So this is our answer, but we can further simplifying it by canceling out the 2's. So the 2's get cancelled, and we're left with negative root y over root x, which is y dash. So when you reach the part where you have your y dash on one side and all your terms on the other side, you have your differentiation completed. So yeah, this is your answer to a question like this. So let's move on to another example. Okay guys, so this question is exactly like the question we just did, except this one has an extra step. Can you find what that extra step is? Okay, so the extra step is that here two variables are being multiplied with each other. And when that happens, we have to use product rule to differentiate. We can't use power rule here, so we're going to use product rule. And here is just normal power rule for the other terms. So we're going to pick our f and our g and our f and our g dash, and then we're going to apply the product rule formula. I'm not going to explain that because I've already explained it before in previous videos, so I'm just going to go ahead and write the product rule, and then we'll expand and simplify and isolate, okay? Okay guys, so here I picked our f and our g, and then I just differentiated those because that's what we do in power rule. I applied the formula here, f times g dash plus g times f dash, that's in the formula sheet. And then I went ahead and differentiated these two terms. The differential of negative y cubed is negative 3y squared y dash. Remember to add the y dash whenever there's a y term. And x squared would differentiate into 2x. Now what we're going to do is simplify whatever I put in the brackets, and we're going to proceed after I do the simplification. Okay guys, So here I just simplified whatever was in the brackets. I just expanded it to each other because it was being multiplied. 4x times 2y dash is 4x y dash plus 2y squared. Bring down the other terms. Now what's different is that we have two terms that have y dash in there. So what we do is we bring the terms with y dash on one side and bring everything else without y dash to the other side. So let's go ahead and do that real quick. All we need to do is move 2y squared to the other side. So our organized equation would be 4xy y dash minus 3y squared y dash equals 2x minus 2y squared. Okay, I'm gonna write that right now. Okay guys, so I organized the equation. The next step is usually my favorite because we have to take out a common y dash term. So we're just going to take out y dash from both terms and put in brackets whatever the remaining is left. So when you take out y dash from this term, you're left with 4xy minus 3y squared. That's it. And then we have our equation organized, and I'll show you what we do after that. Okay guys, I wrote this term where I took out the common y dash. When I take out the common y dash, it's obviously multiplication. You have to multiply it, so when you expand, you get equal to this. So now we just isolate for y dash. Since y dash is being multiplied by this term, we're going to divide this on the other side, so we're left with just y dash. So our final answer would be 2x minus 2y squared divided by 4xy minus 3y squared. Okay, I'm gonna write that out. Sorry guys, I think my video cut off. But anyways, what I was saying is that we isolated for y dash and we divided this term on the other side and we got this as our answer. So that's basically it. Most of implicit differentiation questions are like this, and this is the complete basics of it. So if you need harder examples, you can let me know and I'll make another video on it. But usually these are some of the easiest ones you'll get for implicit differentiation. Okay guys, so thank you guys for watching. This was a pretty short video because I didn't really need to explain much since most of the knowledge we already had. So yeah, if you guys need anything, you can let me know in the comments. Once again, thank you guys for 500 subscribers, and I hope you have a great day. Bye.